Here's another simple word problem from solving right triangles using basic trig ratios. An observer on the top of a cliff 200 feet above the sea level observes the angles of depression of two ships at anchor to be pi/4 and pi/6 respectively. Find the distance between the ships if the line joining them points to the base of the cliff. As always, we need a nice clear diagram. So let's first go ahead and draw a clear diagram. Let's say this is the sea, and we are going to draw the cliff as well. Let's assume that the cliff is somewhere here, and there are two ships. Those two ships, maybe one ship is somewhere right here and the other ship is somewhere right here. Now we will start writing down the given information. How tall is the cliff? The cliff is 200 feet tall. So let's first show that. The height right here is equal to 200. And then we have the angles of depression of two ships to be pi/4 and pi/6 respectively. Let me show the first angle of depression. These are just rough sketches only. The angle of depression for the second ship, far away ship, should be pi/6. When we say angles of depression, they are measured from the horizon. Therefore, I need to also show the horizontal line from the top of the cliff. So let's assume this is that horizontal line. Now let me show the values of those angles. The smaller angle is pi/6. That means this angle right here should be equal to pi/6. The other angle is pi/4. Let me show that other angle this way. All of this angle should be equal to pi/4. Now I have shown all the given information. We need to find the distance between the ships. Let me show the distance between the ships also using a straight line. We need to find this distance. We will assume that the distance between the two ships is L. I need to find L. We have two given angles and the height is given to us as 200. We need to find L right here. Of course, what should be the size of the angle right here? That is the angle between the cliff and the sea. That angle should be equal to 90 degrees. What should be the size of the angle right here? We know that this line is a horizontal line and the sea is also a horizontal line. Therefore, the angle right here should be exactly the same as the angle right here. Therefore, this angle should be equal to pi/4, which makes the angle on the other corner also to be equal to pi/4. Once again, you can see that this triangle right here becomes an isosceles right triangle. Being isosceles means that this side should be equal to this side in length. Therefore, the distance from this point to the first ship should be equal to the height of the cliff, which is 200. We are going to need that information also when solving this problem for L. Now, what can you say about the angle right here? That angle should be exactly same as the angle right here, because we know that this is a horizontal line and this is the sea line, which is also horizontal. Therefore, these two angles should be exactly the same. This means the angle right here should also be equal to pi/6. Now, if I look at this larger triangle, which is also a right triangle, with respect to the angle right here, this side is the opposite side. this side is the adjacent side. Therefore, I can write down a tangent pi over 6 for this angle using that larger triangle. When I do that, I have tangent pi over 6 is equal to opposite, which is 200, divided by adjacent, which is 200 plus L. Please note that the adjacent is all of this length, which is equal to 200 plus L. Now we just have to simplify this equation. We know that tangent pi over 6 is equal to 1 over square root 3. That's equal to 200 divided by 200 plus L. Now 1 and 200 plus L can be multiplied, and then square root 3 and 200 can be multiplied. Then we get 1 times 200 plus L is equal to 200 times square root 3. From that we get L equals 200 square root 3 minus 200. We may simplify this a little bit more. Then we get L equals, we can factor out 200, and then inside parentheses we will have square root 3 minus 1. Please note that this answer should be in feet because the height of the cliff was given in terms of feet. This is the final answer for this problem. Thank you so much.